Assalamu alaikum. Welcome to lecture number 9 of the course on statistics and probability. You will recall that in the last lecture and the lecture before, we have been discussing various measures of central tendency, in other words, averages. We started from the mode, we went on to the arithmetic mean and the weighted mean, and after that we discussed the median. उसके बाद आपको याद होगा कि मीडियन में जो पार्टीशनिंग का कॉन्सेप्ट इन्वॉल्व्ड है, उस कॉन्सेप्ट को हमने आगे बढ़ाया एंड आई टॉक्ड अबाउट द क्वार्टाइल्स, डिसाइल्स एंड परसेंटाइल्स. आज हम सेंट्रल टेंडेंसी के दो और मेजर्स डिस्कस करेंगे, द ज्योमेट्रिक मीन एंड द हार्मोनिक मीन. एंड आफ्टर दैट I will also briefly mention a few other measures of central tendency. So let us begin with the geometric mean. The geometric mean of n positive values x1, x2, so on up to xn is defined as the positive nth root of their product. In other words, g is equal to the nth root of x1 into x2 into x3, so on up to xn, where each of the x values is greater than 0. आप नोट कीजिए कि मैंने आपसे कहा कि ये जो वैल्यूज हैं, these should be positive. आप सोचिए कि अगर आपके डेटा सेट में कोई एक वैल्यू भी 0 के बराबर हुई तो आपका ज्योमेट्रिक मीन जो है that will become 0, because when you multiply that value with all the other values, regardless of whatever the other values might be, this 1 0 value will make the product equal to 0. So that is why the geometric mean is defined in this manner, that it is the nth root of the product of the values when the values are all positive. Negative होंगी तो भी problem आ जाएगा. The second thing to note is that it's easy to apply this formula if the number of data values is not very large. But if you have a considerably large number of values, students, you will agree that it may be quite laborious to find the nth root. Well, of course, if you have a computer at your disposal, then it is not difficult. But if you are doing it with an ordinary calculator, it may be quite difficult to find the 9th root, for example, if you have 9 values. This problem is overcome by the use of logarithms. Taking logarithms to the base 10, our formula becomes log of g is equal to 1 over n times log of x1 plus log of x2 plus so on up to log of xn. ये इसलिए कि जैसा कि आप पहले से जानते हैं, जब भी किसी प्रोडक्ट का लॉग लिया जाता है तो वो सम में कन्वर्ट हो जाता है. दैट इज लॉग ऑफ द प्रोडक्ट इज इक्वल टू द सम ऑफ द लॉगरिथम्स. हेंस द फॉर्मूला बिकम्स log of g is equal to sigma log x over n. But since we are interested in finding g, therefore we take the antilog, and the final formula is that g is equal to antilog of sigma log x over n. Let me apply this concept of the geometric mean to a very simple example. Suppose that we have values 45, 32, 37, 46, 39, 36, 41, 48 and 36. If we want to apply the original formula, then we will need to compute the numerical value of the ninth root of the product of all these values, as you now see on the screen. But in order to simplify the computations, we will take the log of each of these values and we obtain the figures as you now see. Log of 45 is 1.6532, log of 32 gives us 1.5052 and so on. Adding this column of log x, the sum is 14.3870. Dividing that by the total number of observations, that is 9, log of g comes out to be 1.5986. The last step is to take the antilog, and doing so, the geometric mean of these 9 values comes out to be 39.68. ये तो हुआ formula for the geometric mean in case of raw data. Now let us see what will be the modified version of this formula in case of grouped data. As you now see on the screen, the formula in this case will be that g is equal to the nth root of x1 raised to f1 into x2 raised to f2 and so on up to xk raised to fk. In other words, each value of x has to be multiplied by itself f times before we go to the step of taking the nth root. In terms of logarithms, the formula becomes log of g is equal to 1 over n multiplied by f1 into log of x1 plus f2 into log of x2 plus so on up to fk into log of xk, which is equal to sigma f log x over n, and taking the antilogarithm, g is equal to antilog of sigma f log x over n. Obviously, this formula is much easier to handle than the first one in which we had to take all those powers. Students, let me now apply this formula to the example of the EPA mileage ratings that we have been dealing with. As you now see on the screen, the x values, that is the midpoints of the various classes, are 31.45, 34.45, 37.45 and so on, exactly the same as what we had earlier. And now, in order to compute the geometric mean, we have to take the logarithm of each one of these x values and multiply that logarithm by the corresponding frequency. So, in this manner, we obtain the last column that you now see on the screen, and the sum of this column comes out to be 47.3042. Dividing it by the total number of cars that we had, that is 30, we get 1.5768, and taking the antilog of this number, the geometric mean comes out to be 37.74 miles per gallon. You will recall that when we found the arithmetic mean of the same data set, the answer was somewhat different. That is obvious. The formula of the mean is quite different from that of the geometric mean, and so it is obvious that we will have some difference. सवाल ये पैदा होता है कि ये जो मुख्तलिफ फॉर्मूले हमें अवेलेबल हैं, इनमें से किस फॉर्मूले को कहाँ पे अप्लाई किया जाए, किस सिचुएशन में वी शुड अप्लाई द अरिथमेटिक मीन और किस सिचुएशन में हम ज्योमेट्रिक मीन अप्लाई करें. सो द आंसर टू दिस क्वेश्चन एज फार एज द ज्योमेट्रिक मीन इज कंसर्न्ड, let me explain this point to you with the help of an example. Suppose that it is found that a firm's turnover has increased during 4 years by the following amounts. In 1958, it was £2,000, whereas in 1959, it became 2,500, so that the percentage compared with the earlier year is 125. दूसरे लफ्जों में 1959 का जो टर्नओवर है, that is 125% of the turnover of 1958. Similarly, the turnover for 1960 is £5,000, and that is 200% of the turnover of 1959. Also, the turnover for 1961, which is £7,500 sterling, is 150% of the turnover of 1960. तो आपने नोट किया कि ये जो टर्नओवर है उस कंपनी का, ये एक कांस्टेंट रेट से इंक्रीज नहीं कर रहा, बल्कि it is increasing at different rates over different years. Now suppose that the owner of the company is interested in finding the average rate of growth of the turnover per year. If he finds the arithmetic mean, he will obtain 125 plus 200 plus 150 plus 140 divided by 4 equal to 153.75% as the average annual rate of turnover growth. But students, if this percentage is used to calculate the turnover from 1958 to 1962 inclusive, we find that this will give us an incorrect answer. But students, if we use this figure to compute the turnover for the 4 years, we will find that the answer is incorrect. As you now see on the screen, if we utilize this figure, we obtain 153.75% of 2000 equal to 3075, 153.75% of 3075 equal to 4728, 153.75% of 4728 equal to 7269, and 153.75% of 7269 equals 11,176. यानी इस रेट के मुताबिक अगर चलते जाएं तो 1962 में the turnover comes out to be 11,176 pounds sterling, whereas the actual turnover figure for 1962 is 10,500 pounds sterling. Students, आपने देखा कि arithmetic mean ने हमें एक ऐसा figure दिया which gave us an incorrect result at the end. आइए देखते हैं कि अगर हम ज्योमेट्रिक मीन इस्तेमाल करें इस सिचुएशन में तो what do we get in this case? As you now see on the screen, the geometric mean of the turnover figures is 125 into 200 into 150 into 140, and the fourth root of this product comes out to be 151.37%. And if we utilize this value to obtain the individual turnover figures, we find that 151.37% of 2000 is 3027, 151.37% of 3027 is 4583, and continuing in this manner, the final figure comes out to be 10500, exactly the same as what we had in the original data. Students, इस कंप्यूटेशन की इंटरप्रिटेशन हम किस तरह करेंगे? इसकी इंटरप्रिटेशन ये है कि अगर इस कंपनी का टर्नओवर इन तमाम सालों के दौरान एक कांस्टेंट रेट से इंक्रीज करता तो दैट रेट ऑफ ग्रोथ, दैट रेट ऑफ इंक्रीज वुड हैव बीन 51.37%. Please note कीजिए, I did not say 151.37%. I said the rate of increase, if it was constant, if it was the same from year to year, it would be 51.37%. So I hope, students, that this example has been able to convey to you very clearly the kind of situation in which this is the most appropriate average to use. But of course, this kind of a situation is encountered relatively less frequently in practice. जो सबसे ज़्यादा commonly used measure of central tendency है, वो तो बहरहाल arithmetic mean ही है. Let us consider another example that illustrates the interpretation of the geometric mean. Suppose that a factory worker receives a 5% increase in salary this year and a 15% increase next year. It should be noted, students, that a 5% increase in salary means that if the salary was rupees 100 at the beginning of the first year, then it becomes 105 at the beginning of the second year. In other words, the salary at the beginning of the second year is 105% of the salary at the beginning of the first year, or we can say that the value is 1.05. Similarly, it should be noted that a 15% increase in salary means that if the salary was 100 at the beginning of the second year, then it becomes 115 at the beginning of the third year. In other words, the salary at the beginning of the third year is 115% of the salary at the beginning of the second year, or 1.15. Now, students, if we compute the arithmetic mean of these two values, we obtain 1.05 plus 1.15 divided by 2, and that is equal to 1.10. In other words, according to this particular formula, we can say that on the average, the salary at the end of a year is 110% of the salary at the beginning of the year. In other words, according to this formula, the average annual increase is 10%. But students, it is important to note that in this particular situation, it is the geometric mean and not the arithmetic mean that provides the correct answer. The geometric mean of the two values 1.05 and 1.15 comes out to be 1.09886. In other words, according to this particular formula, on the average, the salary at the end of a year is 109.886% of the salary at the beginning of the year. In other words, according to this formula, the average percent increase is 9.886, not 10 as we obtained earlier. Now, in order to verify that it is the geometric mean and not the arithmetic mean that provides the correct answer, students, let us assume that the monthly earning of the factory worker was rupees 3,000 to start with, and he received two increases of 5% and 15% respectively. So, raise number 1 is 3,000 into 0.05, and that is 150 rupees. Therefore, at the beginning of the second year, his salary became rupees 3,150. Also, raise number 2 is rupees 3,150 into 0.15, and that is equal to rupees 472.50. Therefore, students, adding the two increments in salary, the total increment is rupees 622.50. Now, if we calculate the raise according to the geometric mean that we obtained a short while ago, we have rupees 3,000 into 0.09886 equal to rupees 296.58 as raise number 1, and rupees 3,296.58 into 0.09886 equal to rupees 325.90 as raise number 2. And students, if we add these two increments, we obtain rupees 622.48 or 622.5, exactly the same as what we obtained just now when we added the actual two increments. Hence, it is clear that in this type of a situation, it is the geometric mean and not the arithmetic mean that provides the correct answer. The next measure of central tendency that I am going to discuss with you is the harmonic mean. Students, harmonic mean जो है, उसकी definition तो बहुत ही interesting है. It is defined as the reciprocal of the arithmetic mean of the reciprocals of the values. I know, पहली मर्तबा में तो समझ ही नहीं आती कि बात क्या हो रही है. Let me repeat it for you. The harmonic mean is defined as the reciprocal of the arithmetic mean of the reciprocals of the values. Symbolically, it is equal to n over summation 1 over x. जैसे कि आप देख रहे हैं, अगर हम इस फॉर्मूले का रेसिप्रोकल ले लें, दैट विल बी समेशन 1/x डिवाइडेड बाय n। और आप जानते ही हैं कि किसी भी चीज का अगर आप सम लें और टोटल नंबर ऑफ वैल्यूज से डिवाइड कर दें, तो दैट इज द अरिथमेटिक मीन ऑफ दोज क्वांटिटीज। तो अगर समेशन 1/x ओवर n की बात हो रही है, तो इसका यही मतलब है कि हम 1/x यानी x वैल्यूज के जो रेसिप्रोकल्स हैं, उनकी अरिथमेटिक मीन की बात कर रहे हैं। सो दैट थिंग विल बी इक्वल टू 1 over the harmonic mean, and when we take the reciprocal of that, we obtain the harmonic mean, as I said earlier, equal to n over summation 1/x. Now, this is the formula in case of raw data, and in the case of grouped data, that is a frequency distribution, the formula becomes n over summation f into 1/x, where x represents the midpoints of the various classes. Let me illustrate the computation of the harmonic mean with reference to a simple example. Suppose a car travels 100 miles with 10 stops, each stop after an interval of 10 miles. Suppose that the speeds at which the car travels these 10 intervals are 30, 35, 40, 40, 45, 40, 50, 55, 55, and 30 miles per hour respectively. The question is, what is the average speed with which the car traveled the total distance of 100 miles? Once again, पहली बात तो जहन में यही आती है कि अगर हमें एवरेज स्पीड चाहिए, तो we should simply find the arithmetic mean of the 10 speeds that we have. So if we do that, we obtain 30 plus 35 plus so on up to 30 divided by 10, and that is equal to 42 miles per hour. But students, if we study this problem carefully, we will find out that the arithmetic mean that you have just computed, that gives us an incorrect answer. I will explain this point in some detail. जैसा कि आप शुरू से जानते हैं, speed is defined as distance traveled, total distance traveled over the total time taken. इसलिए अगर हमें एवरेज स्पीड चाहिए उस पूरे 100 माइल के इंटरवल के लिए, तो इसका यही मतलब है कि हमें टोटल डिस्टेंस को डिवाइड करना चाहिए बाय द टोटल टाइम टेकन। लेकिन जैसा कि हम जानते हैं, वो जो 10-10 माइल के इंटरवल्स हैं, उन सब में स्पीड्स मुख्तलिफ हैं। सो वी विल हैव टू डू द कॉम्प्यूटेशन स्टेप बाय स्टेप for each one of those intervals. Doing that, for the first interval of 10 miles, the speed is 30 miles per hour, and hence the total time taken to cover that interval of 10 miles will be given by the formula distance over speed, because speed is equal to distance over time. So naturally, time is equal to distance over speed, and applying that, the time comes out to be 10 divided by 30, that is 0.3333 hours. Proceeding in exactly the same manner for all the intervals, we obtain the successive times as 0.2857 hours, 0.2500 hours, and so on. Adding all these times, the total time taken to travel the 100 miles comes out to be 2.4881 hours. And dividing the total distance of 100 miles by the total time taken, that is 2.4881 hours, the true average speed comes out to be 40.2 miles per hour, which is not the same as 42 miles per hour, the figure that we obtained when we found the arithmetic mean. So आपने देखा कि arithmetic mean ने तो हमें इस मर्तबा भी help नहीं किया. Let's see what we get if we apply the harmonic mean in this particular question. We have the column of x, that is the column of speeds, as 30, 35, 40, 40, and so on. And in order to compute the harmonic mean, the first step is to find the reciprocal of each one of these x values. Doing that, the first reciprocal comes out to be 0.0333, the second one as 0.0286, and so on. And adding all of them, sigma 1 over x comes out to be 0.2488. Substituting this value in the formula of the harmonic mean, we obtain 10 over 0.2488 equal to 40.2 miles per hour. And students, this is exactly the same answer as what we obtained a few minutes ago as the correct average speed of this vehicle. Students, harmonic mean को compute करने का तरीका तो आपने देख लिया. Now the key question is, in what situation should we be using the harmonic mean? I think कि by now you might be a bit confused कि पता नहीं कौन सी situation में arithmetic mean और कौन सी situation में geometric और किस situation में harmonic mean use करनी चाहिए. Actually, it's not such a big problem. If we follow 2 or 3 basic rules, the whole thing will become quite simple. The first rule that I would like to draw your attention to is that when values are given as x per y, where x is constant and y is variable, that is the situation when the harmonic mean is the appropriate average to use. ये जो example हमने अभी discuss किया, इसमें हमने देखा कि there is a vehicle which is traveling a total distance of 100 miles, but there are 10 stops in that entire interval of 100 miles. Each stop is after an interval of 10 miles. ये जो point है कि each stop is after an interval of 10 miles, this implies that the distance between any two stops is constant. और अभी मैंने आपको जो rule दिया था, उसमें मैंने कहा था कि when the quantities are expressed as x per y and x is constant, then we use the harmonic mean. अभी इस question में हमने ये कहा कि वो जो distances हैं, they are constant. अगली बात ये थी कि वो जो speed है उस vehicle की, that is changing from interval to interval. In the first interval, it is 30 miles per hour. In the second interval, it is 35, and in the third interval, it is 40. अब सवाल ये है कि ये जो स्पीड पहले इंटरवल में 30 माइल्स पर आवर है, इसका मतलब हुआ कि 30 is a figure which is actually representing distance over time because it is the speed. वो जो अगला फिगर है 35, that is also representing distance over time. और वो जो तीसरा है 40, that is also distance over time. लेकिन distance तीनों में constant है, 10 miles, 10 miles, 10 miles. Distance over time, x per y. x constant हो गया. अब y जो है, distance over time, यानी x per y, यानी y represents time. Time तीनों intervals में vary कर रहा है because the speed is different. I hope that this lengthy discussion has conveyed to you the point that whenever we have such values which are representing rates x per y, and then we have a situation that the numerator x in that problem is constant, but the denominator y is varying, then it is the harmonic mean and not the arithmetic mean, which is the suitable average. और उस situation में हम क्या करेंगे? If we are averaging rates x per y, but it is not x which is constant, rather it is y which is constant. The answer to this question is that in this scenario, it is the arithmetic mean which is the appropriate average. Let me explain this to you with reference to an example. Suppose that there are 10 students in a particular class, and suppose that they obtain the following marks in a test out of 20. 13, 11, 9, 9, 6, 5, 19, 17, 12, and 9. If we find the arithmetic mean, the average marks come out to be 110 over 10, and that is 11. ये जो मैंने अभी arithmetic mean compute की है, I did it in a very simple way. I simply added those 10 marks and divided by 10. But students, अगर आप गौर करें, तो मैंने आपसे ये कहा था कि ये सारे जो marks हैं, they were out of 20. अगर इस एंगल से हम इन 10 marks को देखें, तो आप realize करेंगे that we are dealing with 10 quantities of the form x per y. We have 13 over 20, 11 over 20, 9 over 20, and so on. Adding these 10 quantities and dividing by 10, we obtain 110 over 20 divided by 10, which is 110 over 10 into 20, and which is equal to 11 over 20. Exactly the same result that I obtained a short while ago when I was adding simply the marks and not using the value 20. After all, जब मैंने पहले भी आपसे कहा कि mean marks 11 हैं, तो मेरा मतलब तो यही था ना कि on the average a student is obtaining 11 out of 20. All right, let us now consider another example to illustrate the fact that it is the harmonic mean which is the appropriate average to use in those situations where values are given as x per y and the numerator x is constant and y is variable. Now students, on the first occasion, the investor buys shares at the rate of $45 a share. So we can say that $45 is equivalent to 1 share, or in other words, $1 is equivalent to 1 over 45 of a share, which means that $18,000 are equivalent to 1 over 45 into 18,000 shares, and that is 400 shares. Similarly, on the second occasion, the investor buys shares at the rate of $36 a share. Therefore, if $36 are equivalent to 1 share, then $18,000 are equivalent to 1 over 36 into 18,000 shares, and that is 500 shares. Hence, students, in all, the investor spends 18,000 plus 18,000, that is $36,000 on 400 plus 500, that is 900 shares. In other words, on the average, the investor buys 900 shares at the rate of $40 per share. And this is so obviously because 40 into 900 is equal to 36,000. Now students, instead of carrying out all these lengthy calculations, we find that the harmonic mean yields the same result very quickly. The point to be noted is that since at both occasions the money value of the stock was 18,000, therefore the harmonic mean is the appropriate average to use. Do not forget the rule that when we have expressions like x per y and x is constant, that is the occasion when the harmonic mean is the appropriate average. And in this example, the harmonic mean of the two prices, that is $45 and $36, is computed by the formula n over summation 1 over x, which is equal to 2 over 1 over 45 plus 1 over 36. And upon solving this expression, the harmonic mean comes out to be 40. In other words, the average price that the investor has paid per share is $40, and students, this is exactly the same result as what we arrived at a short while ago. आइए अब हम इन दोनों रूल्स को रिवाइज कर लेते हैं जो मैंने अभी आपके सामने पेश किए. I said that when quantities are expressed as x per y and x is constant, the harmonic mean is the appropriate average to use. But if the quantities expressed as x per y are such that y is constant, then it is the arithmetic mean which is the appropriate average to use. Okay, now we have completed our discussion regarding the arithmetic mean, the geometric mean, and the harmonic mean. Before we bring this particular discussion to an end, students, I would like to convey to you an interesting relationship that exists between these three measures of central tendency, and it is very simple. The relationship is that for any data set, the arithmetic mean is greater than or equal to the geometric mean, and the geometric mean is greater than or equal to the harmonic mean. इसका मतलब ये हुआ कि ऐसा कोई डेटा सेट नहीं हो सकेगा जिसमें arithmetic mean might come out to be smaller in magnitude than the geometric or the harmonic mean, or that the geometric mean comes out to be smaller than the harmonic mean. If all the values in any particular data set are the same, students, in that situation, the arithmetic mean will be exactly equal to the geometric mean, and the geometric mean will be exactly equal to the harmonic mean. ये सिर्फ उस situation में when all the values in a data set are equal. Otherwise, the arithmetic mean will always come out to be greater than the geometric mean, and the geometric mean will come out to be greater than the harmonic mean. Students, मैंने आपके साथ central tendency के 5 most important और most widely used measures discuss कर लिए हैं. The arithmetic, geometric and harmonic means, the median and the mode. But you'll be interested to know that there are some other measures of central tendency as well. 2 of these are the mid-range and the mid-quartile range, and I will discuss them with you one by one. First, the mid-range. Suppose that we have n observations such that the smallest is denoted by x0 and the largest by xm, then the mid-range is defined as x0 plus xm over 2. Students, आइए ज़रा इस फॉर्मूले पर ज्योमेट्रिकल पॉइंट ऑफ व्यू से गौर करते हैं. जाहिर है कि x0 जो स्मॉलेस्ट वैल्यू है, that lies on the extreme left of our distribution, और xm जो maximum value है, that lies on the extreme right of the distribution. जब आप इन दोनों को ऐड करके 2 से डिवाइड करेंगे तो जाहिर है कि उसका जो आंसर होगा that will lie somewhere in the middle of the distribution. The other one that I want to discuss is the mid-quartile range. If we have n observations, x1, x2, so on up to xn, and if q1 and q3 represent their first and third quartiles respectively, then the mid-quartile range is defined as q1 plus q3 over 2. बिल्कुल पहले की तरह, exactly the same logic. If you add the value of q1 with the value of q3 and divide by 2, you will get a value in the middle of your distribution. So in this manner, both the mid-range and the mid-quartile range, they act as measures of central tendency of the data set. ये जो 2 फॉर्मूले मैंने आपको आखिर में दिए हैं, students, I hope that this makes you realize that there are many ways in which you can define measures of central tendency. हो सकता है कि आपके जहन में कोई और फॉर्मूला आ जाए which can be yet a new method of measuring the central tendency of a data set. So why don't you give it a try? Students, we are coming close to the end of today's lecture, and in today's lecture and the one before, we have discussed in detail the concept of central tendency. अगली मर्तबा हम एक और नहायत important concept discuss करेंगे, and that is the concept of dispersion. Dispersion is an important technical term representing the variability that exists in our data set. पेशतर इसके कि हम अगले टॉपिक की तरफ जाएं, I would like to revise with you briefly the core concept of central tendency. जैसा कि मैंने आपसे पहले कहा था, whenever we conduct a statistical inquiry, we collect a certain amount of data, and the first thing a statistician wants to do with this data is to organize it in a summarized and comprehensible form. And we do things like the frequency distribution and the diagrammatic representation like the histogram and the frequency polygon. But students, usually that is not sufficient for our purposes, and the statistician is interested in ascertaining one single number that represents that entire data set in some definite way. This number is called an average, and it is a measure of the central tendency of the data set. As you have noticed, there are many different ways of finding the central tendency, and these various measures, different measures are appropriate in different situations. This brings us to the end of today's lecture. I would like to encourage you to attempt the assignment for this week and also many other problems, as many as you can handle. Next time, inshallah, we will begin the concept of dispersion. Best of luck and Allah Hafiz.